Okay, in this video, we are going to briefly review our negative exponent laws or negative exponent rule. So first, I want us to take a look at what is happening from 2 to the first power and up. So whenever we have 2 to the first power, that's just 1, 2. Whenever we have 2 to the second power, that's 2 multiplied twice. 2 to the third power is 2 multiplied by 3 times, and 2 to the fourth power would be 2 multiplied by 4 times. So each time that I move up my table or up my expressions and I up my exponent, I'm adding another multiple of 2. So 2 to the first, 2 to the second, I multiply by another 2. 2 to the third, I multiply by another 2. 2 to the fourth, I multiply by another 2. So every single time that my exponent is increasing, I'm multiplying by a 2. So now let's look at that in reverse. Every single time that I go down my table, I happen to be removing a 2, but not just removing a 2, the operation is dividing by 2. Okay, so again, as I increase my exponents, I'm multiplying by 2. As I decrease my exponents, I'm dividing by 2, which is how we get to the concept of our negative exponents. So something that we noticed was whenever I continued this pattern of going down my table because I needed to get to exponents that were less than 1, because I know that I can just do 2 times 2, I can keep expanding them. But what happens whenever I have exponents that are also less than 1? So with that being said, I was able to discover a pattern. So 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1, and I continued this pattern. So anything raised to the 0 power is a number 1. And if I do 1 divided by 2, I get a half. A half divided by 2, I get 1/4. And then 1/4 divided by 2, I ended up getting 1/8. And then that divided by 2, I got 1/16. So every single time that I had a negative exponent, really the operation that was happening was division, or the opposite of what you're saying. So -1, think of it as the opposite of 2 to the first power would be 1 over 2 to the first. You're dividing by 2 in this case. Yes, it looks like a fraction, but really this fraction bar means division. So it's really 1 divided by 2. Or in this case, 2 to the second power would be 1 divided by 2 times 2, which is 4. 2 to the negative third power, you think of 1 divided by 2 times 2 times 2 because of your 3 here, which is really 1/8. 1, 2 to the negative fourth power would be 1 divided by 2 times 2 times 2 times 2 because of your exponent 4, which is really 1 divided by 16, or 1/16. So we're going to use all of this as we recap our negative exponents again today. So this should have been on page 8 of your notebook. Page 9 was independent practice if you are watching this while we are doing virtual learning in the 2020-21 school year. And then today we're going to be rediscovering our exponent law with a different pattern. Okay, so in this case, we're going to look at 6 to the second power. And if you want to pause this video for a moment and make sure you have everything from here up written down, go ahead and do so because I'm going to start moving through my pattern here. So first things that I want you to notice is 2 to the second power. All this means is I'm going to multiply 6 2 times. 6 times 6. Okay, 6 to the first power is 1/6. Okay, and here I get a little confused. So let's take it back. 6 to the first power was 1/6. I increased my exponent, so I added another 6. Okay, so each time that I was moving up, or I was increasing exponents, I continued to multiply by additional 6. So if I was to do the expanded form, okay, this here was your expanded. Okay, now I need the value. Well, 6 is equal to 6, but 6 times 6 is equal to 36. So again, as I increase my exponents, I multiplied by an additional 6. So here, 6 to the first power, if I do 6 to the second power, I multiply by another 6, making that 2. Okay, so once I realized that as I increase exponents, I multiplied 6, let's figure out when we decrease exponents. So we're going from 6 to the second down to 6 to the first. I'm going to move in this direction now. In this case, I'm dividing by 6. 36 divided by 6 is 6. 6 divided by 6, again, I'm decreasing my exponents now, is 1 whole. So again, here we see that anything raised to the 0 power is 1. Okay, now if I do 1 divided by 6, again, let's write it as 1 divided by 6. You'll notice it becomes a fraction. Okay, then if I do 1/6 divided by 6 again, that's going to end up being 1 over 36. Okay, so let's take a moment and see what's really happening here. So this part doesn't apply because if it's 0/6s, I can't write out 0/6s. Okay, but let's see what's happening here. In the video that we watched on the Ed puzzle, they also talked about not necessarily just a pattern, but noticing that think of negative as an opposite. So here I multiply by 1/6. In this case, let's do the opposite of that. So the opposite of multiplying is dividing. So let's divide by 1/6, or 6 to the first power, which is equal to 1/6. In this case, I'm going to divide by 6 to the second power. Instead of multiplying when it was positive, let's do the opposite. Okay, and then that expanded is 1 over 6 times 6, which is equal to 36. So again, you can think of it two ways. Whenever you have a negative exponent, we can look at it as they're going to the bottom and denominator part of the fraction, or you're dividing. And then also think of negative as the opposite of multiplying, which again gives you the division concept. So if you'd like to pause this video to make sure that you have this section complete, that would be great because we're going to move on to writing each expression using positive exponents. So let's take a look at number 1. Again, I'm going to go in this thinking that the negative sign means opposite. So this is 2 and we're not multiplying this anymore because 2 to the 5th power would mean I'm multiplying 2 times 2 times 2 times 2 times 2 5 times. Okay, in this case, we're going to do the opposite of that, which means dividing by 2 5 times. So let's do division. And again, we represent division as a fraction bar this time by 5 times. So writing each expression as with positive exponents will just mean 1 over 2 to the 5th. And again, we're going to think of this fraction bar as a division symbol this time. So 1 divided by 2 to the 5th. Okay, and number 2, same concept. There's this opposite here, which means we're going to do 1 divided by, or 1 over 3 to the 4th power. We're not going to multiply anymore, we're going to divide, and the fraction bar is what is representing our division in this case. Okay, negative sign here, so it's the opposite of 5 to the 2nd power, or multiplying 5 twice. We're going to do division, and again, my fraction bar is representing the division sign. Okay, 5 to the 2nd power would just be 5 times 5. But this lets us know we're doing 1 divided by 5 times 5. Okay, same concept with number 4. Okay, this negative sign means that we're going to do the opposite of multiplying, so we have to have division. And again, the fraction bar there is representing our division sign, and it's going to be 6 to the 4th power. What happens on number 5 when it's already division? Well, what is the opposite of dividing? Multiplying. So in this case, we're going to multiply. So we're going to make it positive. So whenever I multiply, it would be 2 times 2 times 2. This was division. Remember, my fraction bar meant the division. And an opposite of that would be multiplying. Same concept here. We have division and a negative. So I need to do the opposite of dividing, and that's going to be multiplying. So we're going to make this positive. 7 to the 5th power. Now this represents multiplication because there's no longer a division or a fraction bar anymore. Okay, so I know this sounds like a lot, but let's start to apply this now. So go ahead and pause if you need to copy this down because I'm going to flip the page over to the back. And we're going to start applying these. Okay, so on the back, it's time to apply. Move the markers out of the way. Okay. see if that helps. Nope, that made it way too dark. Okay, let's let it focus. Okay, now time to apply it. So apply it, number 1. We're going to have 3 to the 6th times 3 to the negative 4th times 2 to the 4th times 2 to the negative 2nd. Okay, so there's 2 ways to look at this. So each positive exponent that I see, I'm going to think we are multiplying it out. Okay, so I'm going to go ahead and put my division bar here because I know I see some negatives, which means I know I'm going to need to divide at some point in time. And again, we're thinking of the fraction bar as division in this case. Okay, so 3 to the 6 is positive, so I'm going to multiply by 3. 6 times. 1, 2, 3, 4, 5, 6. But in this case, I see a negative 4. So that lets me know that I'm going to divide by 4, or divide by 3 4 times. And again, my fraction bar lets me know I'm dividing. Okay, in this case here, I have 2 to the positive 4. It means I'm multiplying by 2 4 times. 1, 2, 3, 4. And in this case, I have 2 to the negative 2nd, which means I'm going to divide by 2. And again, it's going under the fraction bar because this is representing division, my fraction bar. Okay, now that you're here, you're probably like, Miss Sams, what in the world? This is confusing. This is long and complicated. Same concept applies as we have already discovered with our quotient laws. Let's just go ahead and cross off what lines up or simplifies. 3 divided by 3, all of these are 1. I can't divide these anymore, but I can divide the 2's. Okay, now we just count up what we have left. I have 1, 2 positive 3's, so 3 to the 2nd power, and I have 1, 2 positive 2's, 2 to the 2nd power. So I'm finished. That's it. I simplified it. Okay, let's look at another one. See if we can get the hang of it now. Okay, number 2. 5 to the 2nd power times 5 to the 5th power times 5 to the negative 3rd power. Okay, again, I'm going to show you the first way first. So I already see a negative sign, which I know that I'm going to need to divide sometimes. And again, our fraction bar is meaning division in this case. Okay, this number here is positive, so it lets me know I'm going to multiply by 5 2 times. This was also positive, so I'm going to multiply by 5 5 times. 3, 4, 5. Oops, now it's 5. Oh no, this time I have a negative 3. That means I'm going to divide by 5 3 times. And again, my fraction bar means division. Okay, we're going to simplify it. 5 divided by 5, all those reduce to 1, so I'm left with 1, 2, 3, 4 5's. Okay, and at this point, some of you could be, now Miss Sams, I know we already learned about a product law. So why are we expanding stuff? I can make this simpler. You can do so. So if you remember the product law, whenever we multiply exponents with the same base, we add them. So in that case, I'm going to see that these 3's here have the same base, and I'm going to add my exponents. What is 6 plus negative 4? Oh, that's positive 2. Now I have the same bases here. They're both 2's. What's 4 plus negative 2? Oh, that's 2 as well. Okay, you may be onto something, Miss Sams. All of these are the same base. Let me just add my exponents because they're multiplying, technically. Okay, so we're going to do 2 plus 5 plus negative 3. Well, 2 plus 5 is 7 plus negative 3. Oh, that is 4. And look, that's what I got whenever I expanded and then reduced and simplified. Okay, you may be onto something. Let's try number 3. 7 to the negative fourth times 7 to the second times 8 to the second. I saw a negative, so I know I'm going to need to be dividing some way, somehow. Okay, so the first one is we have negative 4. That means I'm going to divide by 7 4 times. Then I have a positive 2. Multiply by 7 twice. Then I also have a positive 2 here. 1, 2, 8. Okay, we only cross off what has the same number. 7 over 7 simplifies. And I no longer have anything else to cross off. So you just count what's left. I have 2 8s and 2 7s. Those cannot reduce. Okay, let's try my exponent law now of adding. Here we have the same bases. Negative 4 plus 2. Okay, Miss Sams, you're right. But that's equal to negative 2. It was on the bottom, right? Okay. And then 8 to the second power stayed on top. Again, remember, if it's a negative 2, that is represented as division, which is why the 7 to the second power had to remain on the bottom of this fraction. Because whenever I added my exponents, I got negative 2, which is represented by having it on the bottom portion or on the denominator. Or again, the fraction bar is meaning the division sign. Okay. 1, maybe 2 more. We'll see. And I ran out of room. Let me scoot it up just a little bit. Okay, number 4. 4 to the negative fourth times 4 to the negative second times 4 to the, well, we'll just do 4. You're going to realize and remember what that means in just a second. On the bottom, we're going to have 4 to the negative fifth. Hold up, Miss Sands. Why are you putting negatives on the bottom? 4 to the negative sixth. Okay, remember from the front, negative just means opposite. Okay, but I do see a lot of negatives, so I know I'm going to need a fraction bar and a division sign in there somewhere. Okay, are you ready? Okay, I see 4 to the negative fourth power. Okay, it is on top, so that means I need to do the opposite of multiplying by 4. So we're going to divide by 4. 1, 2, 3, 4. Okay, here I have another 4 to the negative second. So let's do the opposite of that. 1, 2. Okay, here I have 4 to the invisible 1, and it's positive. So I'm going to do exactly what it says, and I'm going to multiply by 4. I'm not going to do the opposite because this was a positive number. Okay, now here's the tricky part. Now that we are on the bottom portion, I'm going to throw in the color orange. Okay, we have 4 to the negative fifth. Now, since it's on the bottom, it is already representing division. So the opposite of dividing is multiplying. So we're going to multiply by 4 5 times. Okay, again, we have a negative 6. It's already on the bottom, which represents division. So the opposite of that is multiplying. Okay, now that we have expanded everything, we're going to go ahead and cross off what simplifies. 4 over 4, they all cancel and equal 1. So we're just going to keep doing so till we ran out. And we're left with 1, 2, 3, 4, 5, 6. Okay, if you are comfortable with using your exponent laws, you could have here. But be very careful because there's a lot of negatives into play. Okay, let's do one more with negatives also on the bottom. So we are going to do 5 examples. Okay. 3 to the fourth power times 3 to the negative sixth power times 3 to the negative fourth power over 3 to the negative second. Okay. Again, I see negative, so I'm just going to go ahead and put my fraction bar, which represents division out there, and then equals something. Okay, let's get started. So first, I see a positive 4. So that means, okay, that I'm going to multiply, do exactly what it says. So let's expand that out. 1, 2, 3, 4. In this case, I see a negative 6, and it's on top. Okay, so this would mean multiplication, but that negative sign there means division. So I'm going to divide 1, 2, 3, 4, 5, 6. Okay, and we have another negative 4 here. It's on top, which usually means multiplication, but the negative sign means I need to do the opposite of that. So 1, 2, 3, 4. Okay, last one. I have 3 to the negative second, but it's on the bottom. That already is representing division because it's on the bottom piece of that fraction. So the opposite of dividing is multiplying, which is how this set goes on top. Again, it was already on the bottom, which is representing division, remember, divided by, and we have to do the opposite of dividing by negative 2, would be multiplying by, well, expanding it out twice. I don't want to say multiplying by 2 because you're doing 3 times 3 twice, or 2 times. Okay, now we're going to simplify. 1, 2, 3, 4, 5, 6. And we are left with 1, 2, 3, 4 threes on the bottom. We're going to leave those 4 threes on the bottom of my fraction. Okay, wherever they're at is where they stay once you simplify. So 4 threes stay on the bottom. So that has to be representative of that in my final answer. And let's go back to my exponent laws to see why. Just real quick, stay with me. Whenever I multiply by exponents, I'm adding them. So 4 plus negative 6 plus negative 4. So 4 plus negative 4 cancels out to be a 0. So I know that I have negative 6. So 3 to the negative 6 power on top. Divided by 3 to the negative second on the bottom. Wasn't there a rule about dividing exponents with like bases? There was. We subtract them. So let's do negative 6 minus negative 2. Oh no, now this remembers and goes back to our integer laws. We're adding the opposite, so that answer is negative 4, which was represented by division in my final answer. Anytime you have a negative exponent, because that would be 3 to the negative 4th power, anytime you have a negative exponent, you have to do the opposite. So we're doing the 3 to the opposite and multiplying that by 4 times. So it's 1 divided by 3 to the 4th. Again, I know today was a lot, but we're just going to remember that every time we have a negative exponent, we think of the opposite. So, for instance, one last recap. We'll go to the front where there's just a little bit of room by my number 6. Okay, whenever I had, let's use the number 5 to the second power. Okay, there is no negatives in this case. So I'm just going to multiply by 5 2 times. Okay, in this case, 5 to the negative second power, there is a negative sign. So let's read that as opposite. So we're going to do the opposite of multiplying by 5 twice. Well, that would be dividing, and we use that by expanding out using a fraction form, with the fraction bar meaning the sign division. Okay, one last example. If I have 1 over or 1 divided by 5 to the negative second power, we again are going to think of the negative sign as opposite. So we're not going to divide by 5 twice, because opposite, we are in this meant division. Divide by the opposite of that, okay? Which means we're going to multiply by 5 twice. Okay, I know that it was a lot, and today basically just practice, and eventually you're going to catch on to some shortcuts. So again, anytime that you see a negative exponent, we're going to treat that as the word opposite, wherever it's at. If it's on the top, we're going to do the opposite and we're going to divide. If it's on the bottom, we're going to do the opposite of that and multiply. Again, we're going to get used to the shortcuts as we practice. But again, a shortcut to think of is whenever we're going to use the negative sign as the word opposite. So this is multiplication. We're going to do the opposite of that and divide. This is division, and we're going to do the opposite of that and multiply it out. Okay, hope this video has helped, and then I know it's a lot, but best of luck to you.